waves, just the shape of them. I always want to know more about them. And as a civil engineering student, I focus in water resources. So currently I'm in a coastal hydraulics class where I learn all about the different aspects of waves and what we do to prevent waves from destroying coastlines. My speech may be a little bit technical, but I hope that you'll be able to learn about the process of a wave from generation to the shore and coastal protections that we design so you can make decisions about living on the coast and also general beach safety. So first I'm going to start off with some wave properties. Wave is essentially just a transfer of energy across a fluid. In water, this is done through circular motions, as you can see, by different water particles. Stokes' theory assumes that these particles do not move from their beginning position at the end of the cycle, but Dr. C.M. Liu says that this assumption may not be completely correct. It does provide a general good idea of what is happening in a wave. There's also a couple parts of waves. This is the general shape. Right here, this line is the still water line. That's where the water level would be if there wasn't a wave traveling through it. We also have the depth. That's just the distance between the ocean floor and the still water line. Lastly, okay, and then we have the wavelength, and that's just the distance from like either the bottom to bottom of a wave or the top to top of a wave. And then we also have the wave height, and that is going to be the distance from the top of a wave to the bottom. With this, we can learn about the journey that a wave will take, starting with the generation. So most waves that we know of, that we see on a coast, are generated by wind. This is done by lots of, like a big gust of wave that you can see right here, creating little ripples in the water that eventually turn into waves. There's a couple different areas for waves. There's the deep water zone. In this zone, this is where that Dr. Lacoju describes that Stokes' theory is best able to predict wave height and wave energy in this region. It is defined where the depth divided by the length is greater than 1/2. That's more of just like a little thing to understand what's going on. Essentially, as you can see in this drawing right here, the depth does not interact with the formation of the wave at all. The next two region is the transitional and shallow zone. For our purposes, we could just call it the shoaling zone, because in this zone, this is where the wave starts to interact with the bottom of the floor, as you can see here, which causes the height to increase and then the length, to decrease. And this continues to happen. So this continues to happen until it breaks. Dr. J. Lee in Oceanography Journal describes breaking as occurring when the shear stress of a wave is no longer strong enough to hold the wave together. They also go on to discuss that this is where most of the energy is dissipated, which you can see here in the way that the water kind of just moves all around. This is important because it reduces the impact that it has on the coastline. So what we generally want to happen is the water to break offshore and not onshore where we build our structures. When this cannot happen, Ralph Kaiser, in an article published for the American Society of Civil Engineers, describes a couple different processes that we can use to reduce the impact that waves will have. The first, as you can see on the left, is something called beach nourishment, where they bring in sand to kind of reduce the depth in the surrounding region, and then that will cause the waves to break away from the shore and not onto the buildings, as you can see right here. When that isn't possible to do, they will create something called a seawall, which is just a large durable structure that will take all the impact of the wave, as opposed to like a cliff or something getting it that could occur in like a mudslide. With this information, civil engineers like myself can design coastal communities to be safe for everyone else. And for people who aren't civil engineers, like some of you may be in here, you can use this information to learn about the powerful forces and decide if living on the coast is safe enough for you.